Today we'll be covering Newton's method. Newton's method is used to approximate zeros of a function. So it's a little confusing at first, but the first step is to make a chart. So let's make a chart. Let's actually get a function first. The function will be f of x equals x squared minus 2. Okay, so that would be our function, and we're going to use when x1 equals 1. And we're going to go to 2 iterations. 2 iterations means, so let me just write that down, 2 iterations. And that means just basically 2 steps. It'll make more sense when we do the chart. Okay, so the chart, it's n, f, I'm sorry, what am I doing? xn, f of xn, f prime of xn, f of xn over f prime of xn, and then xn minus f of xn over f prime of xn. Okay. Yeah. And then let's make a chart like that so it makes more sense. And you are allowed to use a calculator on this problem, on Newton's method problem, because they do go to decimals, so it would not make sense. So n is just like normally how we define n. It's like 1 and 2. We're going to have just 2 because we're only going to do 2 iterations. And again, Newton's method is to approximate zeros. So this is just another way to approximate your x's when y is 0. Okay, so xn would be 1 because we're starting out with 1 because do you remember they gave us 1, so 1.0. And f of xn would be, when you plug in 1 to f of x, you get 1 squared, which is 1, minus 2 is negative 1. And then you're going to take, and then for f prime of xn, you're going to get the derivative of f of x. So the derivative of f of x is 2x. So then when you plug in 1, you're going to get 2. And now f of xn over f prime of xn is it's negative 1/2, so it's negative 0.5. And then xn minus, so 1.0 minus negative 0.1/2 is 1.5. So that is like, now you're getting closer to the 0, right? But now to get even closer to the your 0, to approximate the best 0, you're going to put 1.5 into the new xn. So you're going to put 1.5 right here, right? And you're going to get, and then now you're going to plug in 1.5 to f of x. F of x is, so 1.5 squared minus 2 is 0.25. Again, you are allowed to use a calculator, so I'm just going quickly because I kind of wrote these down. So 0.25. And now you're going to plug in 1.5 to the f prime. So 2 times 1.5 is 3, obviously. And then, oops, that's a bad 3. Can also get 5. Okay. And then f of x, so 0.25 over 3.0, which is 0.0833. 0.0833. And then you're going to plug in, then you're going to do xn minus f of x over f prime of xn, and you are going to get, so you're basically doing, what is it called? 1.5 minus 0.0833, and you are going to get 1.416667. 1.416667. When you are doing this in the calculator, make sure you write down as many numbers as possible so you are the closest to it. So your answer, since we are only going to 2 iterations, usually in the problem it will tell you how many steps you will go to get your answer, or it'll tell you to get a difference of 0.001 or something. So right here, you see how it's 0.4. We'd say it's a 0.0. It's not even a 0.0. It's 0.1 difference. So you pretty much, you could do this a third time to get even closer, but since it only says 2 iterations, we're only going to go to 2, and your answer would be x equals 1.4166667. And that would be all for the Newton's method.